expect from what should we expect from a limit like this? Well, I'm going to make one more modification, which should be clear. I don't want to take a limit of the piecewise defined function like this. But I can make a following observation here. So this limit I can modify to be like this. F of g of x minus f of g of a over x minus a, right? So I'm just copying the stuff that I have for g of x not equal to g of a. And now let's think about the fancy way of writing 0. So can I write 0 like this? F of g of x minus f of g of a over x minus a. And if this is if g of x equal to g of a. So what do you think? Can I simply replace 0 by exactly the same expression? And the answer is yes, right? Because if g of x is equal to g of a, then the numerator is going to be 0. X is never equal to a when we're taking a limit. And so this is just a fancy way of writing 0. But then I really don't have different prescriptions depending on what the value of g of x is, right? It's always the same expression. So I'm really taking a limit as x goes to a of f of x, f of g of x minus f of g of a over x minus a. And this is nothing but the definition, limit definition, of a derivative of f composition g evaluated at a. And I'm done. Why? Because now I know that on one hand, this limit is equal to f composition g prime of a, but on the other hand, exactly the same limit is equal to the right-hand side of the chain rule. So that means that we proved the chain rule. And you see that we had to go into a bit of trouble because of that problem with g of x potentially being equal to g of a infinitely many times near x equal to a, but we were able to avoid this trouble by working with this auxiliary function that I introduced here. Okay, and in the next lecture then we're going to start talking about more properties of differentiable functions, in particular a very important mean value property.